Hey guys, happy Wednesday. Um, I hope that everybody's doing well today. Um, yesterday we were talking about, finished talking about two-way tables and percentages and relative frequencies and things like that. So today we're going to go ahead and start with that, and then we're going to move into 9.4, which we're not really going to do a lot of mathematics in 9.4. Okay, and we'll get into that in a minute. Um, but just so you know, there's not going to be a lot of math when we talk about 9.4 and doing 9.4. Okay. So if we look at the do now, we had to go ahead and complete our two-way table, right? I completed it already before I started the video just to save a little bit of time because it is going to be a lot of talking in 9.4. And again, we're not doing a lot of math with 9.4 today. So with relative frequencies, we filled out the table. Right? So we use the information that we were given to find the missing values in our two-way table, right? So that was question one, which I did. All right, question two asked us to create a relative frequency table using the two-way table. Okay, so a relative frequency table is basically just like a two-way table, except we're using the frequencies of we're using the joint frequencies to find the percentages of each of these things that are occurring, right? And so we would find the joint. We would use the joint frequency of, let's say, age 18 and likes ice cream, which is 240, and find out what the percentage of that compared to the total is, and put that in the table there. So we're going to skip that part and just be able to answer the questions. All right. So number three asks, what is the proportion of people who prefer ice cream? Right? So we're talking about the proportion of people. So this is just another way of asking for the total. So we're looking at the total here. Right? So we want to know the percent of people who prefer ice cream from the total. So if we look at our two-way table, we see 449 people prefer ice cream out of the 570. So what I can do is 449 divided by 570, and then I can divide that to get about approximately 0.79, and then multiply that by 100 to get that my percent is 79%. Okay, so 79% of people said that they prefer ice cream. All right. So number four, it's asking the proportion of people under 18 and prefer fruit. So I'm looking at my percent of people who prefer, I'm looking at my fruit under 18. That's 5 people that are under 18 that prefer fruit. And we're looking from the total. Proportion of people is the total, right? So 5 people out of the total. 5 out of 570 people said that they prefer fruit that are under 18. So 5 out of 570, we divide that, we get approximately, I think it's about 0.088, and then a bunch of other numbers. We can round that up to being, or 0.0088, some. Which then when we multiply that by 100, we're going to get approximately 1%, right? So 5 out of 570, approximately 1% of people that are under 18 that prefer fruit. Okay? So we want to know what the meaning of the relative frequency 0.056. And so what we can say is that approximately 6% of people fit that category. So we'll go ahead and write that in. So approximately 6% of people fit that category. Okay, so approximately 6% of people fit into that category, whatever the category might be. Right, so I'm just rounding up to the nearest percent, or the nearest, in this case, hundredth, to be able to find my percent. So approximately 6% of people fit into that category. Okay. And then lastly, number 6 is asking what percent of people are 18 and older and prefer cookies. So again, percent of people, this is going to be the total, right? That's what that's asking for, the total. So out of 570. And so we're looking at 18 and older who prefer cookies. So that's 19 people that are over 18 that prefer cookies. And so when we divide that, we get approximately 0.033 repeating, I think. And then when we multiply that by 100, we'll get that this is approximately 3% of people who are over 18 and prefer cookies. All right, so this is just how we're answering questions based on our relative frequencies. And so again, relative frequencies are just our percents. Okay. So again, if we had trouble with this, please feel free to reach out. Okay, pause the video, reach out so that we can go ahead and talk through this before you move on. All right, so like I said, let's move into 9.4 now. This is going to be a lot more talking than there is going to be mathematical stuff. It's really a lot of analyzing and explaining reasonings behind different data displays. And so that's actually the title of 9.4. And so 9.4 is about data displays. And so we've already kind of talked about a couple of different data displays in 9.1 to 9.3, right? And so we've talked about scatter plots. We've talked about two-way tables between the last couple of days. So we're going to start talking about these different kinds of data displays that you can come across, right? And so after we kind of talk through each data display, we're going to start identifying what we think the best data display will be for the set that we're given, right? So below we have a screenshot. We have the screenshot here that's from your book that kind of summarizes each data display that you might come across and what it does. It's a really good resource to have when you're studying how and why to choose an appropriate data display, right? So we have a pictograph, and so this is we've seen this before. This just shows data in pictures, right? So we see that we have those birds there, and we have the categories A, B, C, D, right? And how often they might occur, or how often you might see them. Maybe this is showing like how many birds you see per day. Maybe A, B, C, D represents the day, and so you see maybe 3 birds on the first day, but only 1 bird the second day, something like that. So when you want to use a pictograph to make data, and I'm actually going to go on because I don't really have a lot of room. Visually appealing. Right. So I'm actually going to move this over a little bit. There it is. All right. So next we have a bar graph, and so it shows data in specific categories. This is where we're comparing different categories to track maybe something over time. So a good time to use this is when you're dealing with categories over time, right? So you might see something like, you could talk about the change of grades over time, and so that actually is probably more of a scatter plot example, or a line graph example. But you can talk about how well someone is doing in a poll. Like if we had a student body president, and so we were looking at how well the different candidates were doing. We can even look at that for our presidential campaign this year. Right now it's just the Democratic nominees that are, going to be in the polls. So we can look at how well each candidate is doing in the Democratic race. Okay, so we're dealing with categories over time with bar graph. With a circle graph, you're showing data as parts of a whole, right? So you're showing this, you're trying to compare parts of a whole. So you would use this when you're comparing parts to a whole. Okay. So this, you see a lot of this, like these circle graphs, these pie graphs, like that they show percentages and things like that. It's really easy to show that. You see a lot of that with a circle graph. So just go with that. Okay. So next we have a line graph. And so this shows how data changes over time. And so this kind of tracks over short and long periods of time how certain things might change. And so you could actually probably create a line graph based on maybe your grades, right? You could go ahead and do, okay, so on the x-axis you could do like assignment, and then on the y-axis you could do the grade. And so you can kind of check and do a line graph and see how you're doing in any class or just in your classes in general. So when to use a line graph is probably for longer periods of time, right? Bar graphs are good for short periods of time. So longer periods of time, right? And so shorter is probably going to be better for bar graph. All right. So a histogram shows the frequencies of data values in intervals of the same size. So this is just showing how often something occurs. And so this is very numerical category. So this could be like an age range and how often, if we were to look at different age ranges and how often, let's say, they take out their dog, for example, right? And so if you could have your age ranges being like 10 to 12, 13 to 15, and then seeing how often they, each age range kind of takes out their dog is a good example for a histogram. So we would kind of want to go ahead and use this when we're showing how often numerical, and I want to stress that this is numerical categories, occur, right? Whereas with a bar graph, these are categories like a candidate in a presidential campaign or something like that, right? So that's very categorical, we'll call it. All right. Next, we have a stem and leaf plot, and so this shows the orders of numerical data and shows how they are distributed. So this is also showing how often something occurs. Right? And so, you can also use the same data that you would use for a histogram in a stem and leaf plot, right? So they're both kind of the same type of idea of, showing how often something occurs, right? So box and whisker plot, we show the variability of a data set by using quartiles. And so when you have multiple different, you probably see a lot of this with I know that I see this when I have to look at, my grades in my master's degree program. It can show you where your grade is based on everyone else's, right? And so this shows when you have multiple different data sets, a large number of data sets, you can go ahead and use it to display how someone is doing or how they did in comparison to the other. So you would use this when you are comparing multiple data sets, right? And so, like I said, you could do that with, comparing, for one individual assignment, we could create a box and whisker plot for how well or how poorly, we are doing as a class. So if we, for example, did for the quiz that we took on last Friday, we could go ahead and create a box and whisker plot to see the highest grade, to see the lowest grade, and what was kind of the middle points, the quartiles, and the median point for that data set. All right, and I know that we've heard of a lot of these already. I just want to go ahead and reiterate and make sure that we're all good with these, especially box and whisker plot. I got that question. If we were going to be doing that again this year when I told you that we were going to be moving on to data, just data in general for chapter 9. All right. So next we have a dot plot, and so this shows the number of times each value occurs in a data set. So again, it's used to show how often something occurs, right? And so this is actually more useful to highlight clusters of data or gaps, right? Okay. And so lastly, a scatter plot. This shows the relationship between two data sets by using ordered pairs in a coordinate plane. And so we talked in detail last week of scatter plots and trend lines and things like that. And so this is basically just when we're comparing two different data sets, right? That's how we know that we're going to use this. So we're comparing two different data sets. Okay. So this is kind of a nice way to go ahead and summarize the different data displays that you might see, and when to use them. If you missed anything, please feel free to rewind and try and make out what it is that I'm writing, because I know that I had to write really small and in a close proximity here. So please go ahead and rewind and make sure that you're good to go. So like I said, we talked through the different data displays that we might see. So now I want to talk about different situations and different data sets that we might see that we have to choose a specific type of data display for that scenario. So if I'm choosing an appropriate data display for, say, the number of students in a marching band each year, each year of that scenario tells me that this is a change over time, right? So as we talked about before, from the best data display to use with change over time is a line graph. And so I need to go ahead and pay attention to those scenarios, right? I'm going to pay attention to scenarios. To know which data display to use. Okay. Right. And so in that scenario, it says the number of students in a marching band each year. Right. So each year is the part of that scenario that tells me that this is going to be change over time. And so I know from our talk, just a minute ago, that anytime we're talking about change over time, we could do a line graph or even like a bar graph. But since it is a kind of each year, this is kind of probably a longer period of time. So we want to use a line graph here as opposed to a bar graph because of the period of time, and each year being probably going to be a longer period of time that we'll have been recording our data. All right. So in our examples, we need to choose an appropriate data display for the situation. And so we're going to explain the reasoning, right? So in number 1, it says a comparison of people's shoe sizes and their heights, right? So if we're looking at this, I'm comparing a comparison of people's shoe sizes and their heights. So here I'm comparing two different data sets, right? So if I'm comparing two different data sets, as we have talked about almost ad nauseum here, we're going to use a scatter plot, because we are, and I'll write it here, we are comparing two different data sets. Okay, so scatter plot because we're comparing two different data sets. All right, and number 2, the percent of students in your school who play basketball, football, soccer, or lacrosse. Right, so the percent of students in your school who play basketball, football, soccer, or lacrosse. And so what we could do, there's a couple of different options here, not saying that one is better than the other, but there are a couple of different options. Since we were talking about percents, the first thing that might have come to your head was a circle graph, and so that's absolutely a good opportunity to go ahead and use a circle graph. You can also here use a bar graph, right? You can use a bar graph because it shows data in specific categories, right? Those specific categories being basketball, football, soccer, or lacrosse. Those are very specific categories, right? So a bar graph would probably be really good for that. A circle graph would also be acceptable there as well, right? So as we can see, there's multiple different answers that are available for use during, when we're talking about this this data here, right? Just making sure that you have a good answer or a good explanation on why it is that you're going to go ahead and use that type of data display is what's important here, right? So it needs to make sense for that data, right? Your explanation is what needs to make sense for the data. So lastly, we have a student's test scores and how the scores are spread out. So I can use a couple of things here. I can use a stem and leaf plot, right? I can use a stem and leaf plot. And so with a stem and leaf plot, that shows how the data is distributed, right? So stem and leaf plot shows how data is distributed, right? So this shows how the data is distributed. Could probably also use here maybe a scatter plot, because we're comparing the student test scores and how those are spread out, right? Also a viable option as well. With stem and leaf plot is numerical data, right, and shows how they're distributed. Okay. So if we're having trouble trying to figure out, or what we're doing here, please reach out. Okay, do not just sit there, for a while, quote unquote, for a while, and not do anything about it. All right. So next page is one thing to be aware of. There's not always a right answer. Some situations can use two different data displays. For example, for number 3, we said a stem and leaf plot would be best because it can show how data is distributed. However, a histogram does the same thing. It just presents it in a different way, right? So choosing an appropriate display is more of an art than science, because it's clearly possible to use any of the graphs to display data, right? So if it is not an appropriate display, then what happens is it'll be what's called a misleading data display. And so this actually leads us into the last part of 9.4, which talks about these misleading data displays and how to identify one. Right, so sometimes graphs are misleading or confusing. This means they are, I'll go ahead and rewrite misleading, because they try to make you think the way that they want you to think, right? So how can they be misleading? And so we're going to see a bunch of different options. How can a graph be misleading? And so for number one, what we can look at, if we look at these graphs, right? These graphs are showing the exact same thing, except in the first graph, in what's categorized as the misleading graph, it makes it look like the Democrats are far ahead of the other two categories, the Republicans and the Independents. Right? That's what it makes it look like. So what we can go ahead and write is that the first way that this can be misleading is that the scales on the axes are wrong, or off, not wrong, off. Are off. Okay, and so what we can write for this for what the first graph makes me think is that the Democrats are really far ahead, right? And so if we look at the not misleading graph to the right, we can see that they are ahead, but not by as much as it looks like in the first graph. And so the reason that is because that scale on the y-axis, if we look at it, it starts at 53 and then ends at 63. So it makes it look like our Republicans and our Independents are really far behind, even though they're only at 54 and they're at 62. Right, so we want to go ahead and pay attention to the axes, and just make sure that those are correct. Okay, so going on to the next ones. For number 2, we can have that the pictures or displays are too big. Sorry. Right? And so if we look at this, I look at my misleading graph on the left, right? And so it looks like our panda population was really big, right? It looks like our panda population was huge compared to 1975 and 1985, right? So this first graph we can go ahead and write makes me think that in 1965, the panda population was huge, right? And so when we look at the not misleading graph of the same data, they're saying the same thing, we can see that there is that decline, but it's not as big as it looks like in number 1. Right, so the reason again that we're doing this is so that we can make sure that we're looking at the correct data so that we can make these correct decisions, right? Because that's what data is all about. It's about looking at different things that are collected and being able to make an educated decision or an educated guess based on that decision. Okay, and so lastly, in number 3, what we can say is that for the third way that this can be misleading is that the ranges are not consistent. And so if I look at this graph, I'm looking at it and it looks like it's telling me that there really is no difference between ages and receiving a speeding violation. right? And so if I look at this data, my age ranges, right? I'll go ahead and I'll erase the bottom part of that G. So if we're looking at this, my age ranges are a little bit off, right? So I go 15 to 16 in that first bar, but then I go 17 to 19, right? So if I look at this, this is 1 year. This then becomes 2 years. Then, so 1 year, this becomes 2 years. Then 20 to 24, that's going to be 4 years. And then 26 to 60, and that's a whole mess, right? So these age ranges are really off, right? So that's how I know that this is not, this is not a good graph, because my ranges are not the same, right? They're not consistent, right? So this is not going to be a good representation of these graphs, right? This looks like that when you're in your early to mid 20s, you would get the same number as when you're 26 to 60, and so that's a little bit misleading if you're trying to compare which age range receives the most speeding tickets or speeding violations. Okay, so lastly, I want to talk about why people would make these misleading graphs. And so sometimes people use misleading graphs to try and sell us something or believe that something is really good or really bad. And so again, this is why we go ahead and we're talking about these misleading graphs, because we see data all the time. We see it in the news, we see it, on billboards, we see it everywhere. There's data everywhere. So being able to look at that data and being able to tell whether what they're saying is actually true is what's really important here, right? We need to be able to tell if somebody's just trying to sell us something, or if something's really good, or if it's really bad, depending on what they're trying to sell, right? So for example, in example 1, the misleading graph makes us believe that Democrats did really well, when in actuality it was actually a pretty close race. They only would have won by 8 votes, we'll say, for example, right? And then in example 3, the misleading graph makes us believe that people in the age range of 20 to 60 are the worst drivers, when in reality, the range of 26 to 60 is very large, so there's more driving offenses or tickets, right? And so again, like I was saying, because those age ranges are not consistent, that's what makes this misleading, right? And so I want to go ahead and talk through quickly about why these 3 graphs are misleading, and then you can look at some common reasons why a graph might be misleading below, right, on that last page there of the notes. All right, so in this first example, I have a circle graph, and so I have that dogs makes up 41% of favorite pets, 32% is cats, but then 27 is a fish. And so I'm sure you could probably look at this and tell right off the bat that this is misleading, because my fish is the lowest possible percent, yet it's the biggest piece of the pie, right? And so what we can say for our circle graph here, right, is that each size varies in each piece of the circle or pie varies in size, right? It's not proportional to the percent given, right? And so that's why that would be misleading, right? And so in the second one, this is kind of like our panda example on the other page, where it looks like the third rock band sold a lot more tickets than the other 2 rock bands, when in actuality, if we looked at this on a proper graph, we would see that there's probably not so much of a difference between the three bands as it makes it look in our pictograph here. So we can say that the tickets vary in width and so the tickets vary in width. So we'll leave it at that. All right. And so lastly, we have this graph here, this bar graph. And so it's a little bit more subtle than the other two. But if we look at this, we have this 1, and then 2 looks like it gets a little bit bigger, 3 even bigger, 4 even bigger, and 5 is the biggest. And so it looks like in this 5th year, this company is trying to emphasize that this is the most money that they've made, right? That they've continued to grow, right? And so this is misleading because the bars become wider as the years go on. Okay. All right. And so, like I said, you can go ahead and look over the common reasons why we might see some graphs that are misleading, or common reasons on why a graph is misleading on your own. All right, and then you can just go ahead and work on the homework. Okay. So if there are any questions, again, please reach out. Otherwise, have a really great day. We'll talk soon. Thanks, guys.